All right. So today is going to be a continuation of our notes from yesterday in class. Um, to find the solution of a linear system, um, remember we're looking for the points where the two lines intersect. There are three possible solutions. There can be no solution, one solution, or infinitely many solutions. So today we're going to talk about how to find the solution of a linear system using a table. You must find where both equations have the same ordered pair in their tables, meaning the x and y. So we're going to start off with number 7. It says use the table to find an x value that gives you the same y value for both equations. So we're going to be filling in the tables for each equation. Now we're given that x is 0. So what we would do is plug in for x in each of these equations each value. For instance, we're going to start off with 0 and see what we come out with. Well, 2 times 0 plus 15 is just 15. 4 times 0 plus 7 is just 7. All right. These two do not have the same number, so they don't have the same ordered pair. But we're going to do that for 1, 2, 3, 4, and 5. Okay. So now that we've done the 0 part, we're going to plug in 1. All right. 2 times 1 plus 15 is 17. 4 times 1 plus 7 is 11. All right. Now we're going to do 2. 2 times 2 plus 15 is 19. And then here, 4 times 2 plus 7, that's 15. All right. Notice that the slope here is 2, so we can just increase here by 2, and we'll get the next number, 21. Notice the slope here is 4, so we just increase by 4, and we get our next number, which is 19. And we can do that again here, plus 2, 23, plus 4 here. What do you know? 23. All right. And then we're going to go ahead to 5 so we can fill that in. Plus 2 would be 25 here, and plus 4 would be 27. So of all these numbers that we see, this has the same ordered pair. Remember, in a table, we're finding where both equations have the same ordered pair. And that's right here at 423. So the solution to this system is 423. Now it says use a calculator, so we're going to do that. All right, I'm going to kind of slide over here. If we're to look here, we're going to need Desmos, so we can go to desmos.com, tap graphing calculator. Right here for number 1, we're going to type in y equals 2x plus 15. All right, that's the first one. And then we're going to tap here on the second equation and type in y equals 4x plus 7. Okay, I misstepped somewhere. So let's go back. Y equals, all right, 4x plus 7. All right. So if we look here on this Desmos calculator, the point of intersection is right about here. And all we have to do is tap at that intersection, and it's going to give us a point. And it showed us the point 423. And that's exactly what we got when we did it by hand, 423. And so you don't have to do it the first way. Just plug it in the calculator. It's going to give you the point of intersection. But I did want to show you how to do that by hand. All right, so now we're going to number 8. Identify the solution to the system given in the tables below. All right, we can't necessarily tell what the equations are here, so we're not going to use the calculator. We're going to use our brain. We're going to come here, and in the first table, we see -10, -6, 3, 15, and all the outputs that go with each of those inputs. And then we see -3, -1, 1, 3, and all the outputs that goes with those inputs right here. These are the outputs. So hopefully what we notice if we study these two tables is that there's a 3, 4 here, and there's a 3, 4 here, which means that these two systems, even though we don't know their equations, we could write one if we wanted to, but no need. All we need to know is that the solution to the system is the point where both of these tables have the same ordered pair. So the solution is 3, 4. That is the solution. And we're actually done with this one. Now, number 9, it says use the table function in your calculator to identify the solution to the given linear system. Use the calculator. All right, so we're going to kind of exit out of this, and now we're going to type in y equals -3x plus 1 in Desmos. Remember, when we're typing the negative in Desmos, we're just using that subtraction symbol. All right, for the second equation, we're typing y equals 5x minus 31. All right, and we're looking for the point of intersection. It seems to be down here in our fourth quadrant. So right about here, once you tap on it, it's going to tell you where the intersection is, and it seems to be at 4, -11. So that's what we're going to write here, 4, -11. That's the solution to the system. All right, now we're going to talk about what if we're given a point and we have to say whether or not it is a solution or not to a system. So in number 10, we're given -3, 1. And it says determine if the given ordered pair is a solution to the system. Well, notice -3 is our x, 1 is our y, and we're going to plug that into each equation to see whether or not it gives us a true statement. For instance, in this first one, we have x plus y equals -2. So we're going to type in for x, -3 plus 1 equals -2. Is this a true statement? Well, -3 plus 1 is -2. -2 is equal to -2. Therefore, yep, it's a true statement, at least for that one. Now, let's go to the next one. All right, we have x, so that's going to be -3 plus 5 times 1 equals 2. Is this a true statement? All right, is this a true statement? Well, -3 plus 5, is that 2? Yes, it is. So it's a true statement. Therefore, -3, 1 is the solution to this system. It is the solution to the system. Now let's try 5, 2 and number 11 to see if it is the solution to 2x minus 3y equals 4 and 2x plus 8y equals 11. So we're going to do what I like to call plugging and chug. This is 2 times 5 minus 3 times 2 equals 4, right? Is this a true statement? And you may say, what did you do? I just plugged in for x 5, right? And for y 2. Plugged it in, and I'm just checking, simplifying to see if it's equal to 4. So this is 10, and then 3 times 2 is 6, so 10 minus 6, is that equal to 4? Well, yes, it is. Therefore, we know 5, 2 is true for 2x minus 3y equals 4. It is a point on that line. But now we need to check 2x plus 8y equals 11. So it becomes 2 times 5 plus 8 times 2 equals 11. Well, let's see. So this becomes 10 plus 16 equals 11. Is this true? Well, this is 26. Is 26 equal to 11? Hopefully by now you said no, right? So 5, 2 is not a solution to this system. Answer is no. 5, 2 is not a solution to the system. All right, now we're going to work on the rest of our practice problems. That's going to be 2, 3, 5, 7, and 6. All right, guys, have a good one.